All right, let's talk about Newton's first law. Here's the ceiling and a rope coming down and a block attached to this rope, and then another rope, and we're going to pull on this rope. This string is very thin, close to breaking. If I pull really fast, what will happen? Which one of these guys will break? And the answer is, if I pull fast, bottom string breaks. Why? This thing has inertia. It's nice. It's there. This force that you're pulling on doesn't have time to accelerate this block before this rope breaks. If I pull slow, however, the top rope breaks. Why? Well, because the top rope would be having two forces on it, the weight of the block and your pull. So in this case, when I pull slow, it's the top guy that breaks. Another example, got some stack of pennies. I flick one of these pennies along the desk. It's zipping along. It smacks into this pile of pennies. What happens? Only the bottom penny flies off. Okay? Why? Because this only applied a force to this moving penny, only applied a force to the bottom guy, only accelerated the bottom guy. So it's the only one that moves. The other ones don't get the force, don't move. Next guy, oh, we know what's going to happen here. Oh, it was a bad scene. Person's not wearing his seatbelt as he flies along on his little wagon, cart, whatever you want to call it here. Big wall coming up. What's going to happen? Blood everywhere. Why? Because when the cart stopped, she kept going into the wall. Okay? Another example of Newton's first law. Here it is here. The net force acting on an object is zero. The object will maintain its state of rest or constant velocity. This is an example of constant velocity. Yes? There is no net force acting on the person. The only net force was acting on the car, because the car is what hit the wall first. So the person maintains its state of rest, its constant velocity, bang into the wall. Yes. So here I am. Yes. I do not move if I'm just standing here until some force acts on me, some unbalanced net force. Yes. At that point, if the force is big enough, I will begin to accelerate. And the same thing happens with a car. After I'm driving along on the highway, the car the person driving the car eases up on the gas a little bit after he gets to whatever speed he wants to go, because at that point, all we need is the engine to balance out friction. Yes, we want these two things to be balanced, and then this car will move with a constant velocity. This is Newton's first law. An object at rest tends to stay at rest. Sometimes how it's portrayed, okay? But it's a fairly straightforward example of. These are fairly straightforward examples of Newton's first law. Ta-da!